Okay. Good evening, ladies and gentlemen. I want to appreciate you all, NICE and Nigerian Society of Engineers, and Nigerian Institution of Structural Engineer, Civil Engineers for the invitation and the honor given me. I promise to do justice to the presentation within a short period of time. As you can see, the title is a bit catchy. Modern day application of ground penetrating radar technique to civil engineering infrastructure investigations. Since 1999, what I've been doing basically in Nigeria, I started using GPR 1999 in Nigeria. And most of the work that I've been doing is basically civil engineering. So most people ask me, am I a civil engineer? I'm not. I'm a geologist, turned geophysicist, not an engineer yet. So, but let me quickly, I'm in Lagos presently, so I can tell you the beauty of it. I'm in Lagos presently. Lagos State government has proposed to build the 4th mainland bridge. The 4th mainland bridge is 38.3 kilometers. And in the last 30 days, we have been carrying out ground penetrating radar investigation along that stretch of 38.3 kilometers. Just to tell you, that's just by introduction. So you should know that GPR, or ground penetrating radar, is a non-destructive technique, very non-destructive. It's a non-invasive, it's a non-destructive technique that is applied. It was first used by electrical engineers, followed by civil engineers worldwide. That's why. And what it does, within the system, within the equipment which I'm going to show, electromagnetic wave will emanate from the system. It's just like a photocopy machine, like a scanner. The EM wave is emitted at a particular frequency. With that particular frequency, whatever object that is along it, that EM wave will be able to image or scan it properly. And GPR, the application started in the early 50s, and it's been used extensively to map buried infrastructures, surface infrastructures. I will mention for locating rivers, voids, cracks in concrete, inspection of foundation, asphalt, and so on and so forth. I'll quickly give 2 examples. There's an hotel in Lagos. They observe that the pie of the hotels, they observe some cracks on the wall somewhere at Ikatelegushi in Lekki. The cracks appearing, and there's a place called Lekki Gardens and Ikoyi Forshaw 2, Forshaw 1. Most of the building there, they're having structural problem. And what we have done in the last 6-7 years is to effectively use GPR to find out the source of this problem. And also at a place called Badia in Lagos, that has been used, and very recently also, Cadbury in Lagos, Guinness in Lagos, Guinness in Benin City, and Benin Medical Center. They observed some defect in their infrastructures. So, and they cannot put out these infrastructures. So we brought in our technique, which is GPR, which I've said is a non-invasive method that was used to scan the wall, the floor, the tiles, and to tell them the cause of the cracks that were observed all over the place. And we should say it's a very sensitive technique, but there's this question that people always ask: is it safe? Since EM wave, electromagnetic wave, any question? EM wave is being emitted. Is it safe to use it? The question is, yes, it is safe. Yes, it is safe to use technology because the wave that is being emitted does not in any way affect the surrounding. As the name implies, radar or radio frequency wave of low power is usually emitted. And this wave will not or does not affect the surroundings or the materials in which, because the antenna, I'm going to show it as we go along, the antenna is always shielded. It's always shielded. So whatever wave that is emanating from the source, they are concentrated and they are transmitted right down into the subsurface. As I've said, it's a non-invasive technique, and what we call this what? An NDT technique. When I say NDT, it's a non-destructive technique. Like this morning, we were somewhere at Ibrahim at Ajah, and we want to check some things. We want to check some cables, buried pipe, subsidence, oh, we cannot remove the ties, we cannot remove the interlock. If you've been to my WhatsApp status, you see the video that I uploaded this morning. We're able to scan the whole surroundings and detect where the defects were. So, as I said, it's a non-destructive technique. It's an NDT. So, if you get some book, they might call it. So, what is NDT? It's the process of doing inspection. So, you can use it for doing inspection, to do testing, to evaluate your materials. To evaluate your material that you have. When I say material, building materials, or if I mention, I remember now, there's a place called Abutu, Alita, in Ondo State, close to Tiupa. There's a bridge that was subsiding. We brought our GP out there in 2014, and we're able to know or to tell the engineer, the structural engineer, the source of the subsidy that they observed on the Abutu, Alita bridge. As I said, it's a non-invasive, and the method does not harm the environment in any way. It does not harm the environment in any way. These have said that GPR send EM wave into the ground through a transmitter, which I'm going to show. It is waves will be transmitted, and it's also reflected when it's observed a dielectric constant difference in material. So you can effectively monitor what is happening. Is the reflected wave that is captured in the system. And the antenna, the transmitter that's used, it can either be monostatic or bistatic. It depends on what you want. But most time, I use monostatic. In the monostatic, both the transmitter and the receiver, they are embedded within the same unit. I will not bother you much about this equation, but I'll just go to the last three things. There's omega, there's mu, there's epsilon, and there's sigma. What are these four things? Most people that have used GPR in Nigeria, they have made mistake. Mistake in the sense that the depth of investigation of a GPR is controlled by these four factors: the frequency of the antenna, the permeability or the magnetic permeability of the soil or the material that we are testing, the dielectric permittivity of the material, and the conductivity of the material. So if you want to use the equipment, whatever material that you want to use, you must know the frequency to be used, you must know the permeability of the environment, permittivity of the environment, and conductivity. Once you have this and you set them into the equipment, you will be able to scan properly the subsurface or the material that you are interested in. Here is a picture from Mala Geoscience, Sweden. This is the monostatic equipment. This is the office in, and you can see here, when I said it's on a wheel, we tested one in Lagos today. We brought one to Lagos from Sweden, and we tested it, and for that, it's working very fine. And here, this is the antenna. That is the antenna, a shielded antenna. When I say shielded, the wave will concentrate and go directly into where you direct it to. And that's the console there. It has a display console where you can immediately see the information of interest, where there's defect, at what depth, and so on and so forth. And I'm also showing the drone. The beauty of it, there's also the drone tile. This is also from Mala. They call it GeoDrone. If you have a difficult terrain or you want to map pipeline, oil pipeline, or gas pipeline that are a bit defective, and with the situation in Nigeria's security network, you don't have to send personnel there. You can send the Mala Geoscience GeoDrone with, at the base here, you are seeing here the transmitter and receiving antenna, and the console. And this is the drone. It will fly. I will show you the example. It will fly over the place, and you can immediately image. And also for bathymetry, So I can go ahead. For example, this is strictly for engineers. This handheld GPR facility. This handheld GPR facilities. You want, as I said, I mentioned an example of Benin Medical Center. If you get there until resin injection was done, we detected where the fault was coming from, cracks all over the world at Benin Medical Center, at Upper Adesua. We're able to scan the wall, scan the subsurface, and we're able to know that, oh, the soil is having problem in a particular area. So engineers were calling and resin were injected to stabilize the soil. So this is a typical example of an handheld GP. I'm not marketing for anybody. I'm just trying to show that most of my work are sponsored by Mala Geoscience or Mala in Sweden. This is also an handheld. So let's assume you want to scan the wall or rod, 18 mm 10 mm rod, or pile. You can use this handheld, or the concrete. You can use this handheld GPR to effectively monitor. As I said, for the example here, it has a shielded antenna and it's a monostatic antenna. But both the transmitter and the receiver, they are embedded. It's very light, less than 1 kilogram. And once you acquire data, that's where people run from. The data, yeah, in different formats. So some little processing, I will not go into detail here, some little processing or little correction, because there will be noise, there will be environmental noise, there will be some cases instrumental noise, and in some cases there will be human noise, so which you have to filter. So there, I will not go into detail, but there are little filtering, band pass, low pass, high pass, deconvolution, migration, and so on and so forth, that has to be done on the data. Now, the trust now, what are the engineering application of ground penetrating radar? Ground penetrating radar can be used for a host of things. And all the things that I've listed here, except 3, I've tested, I've used them in Nigeria extensively, in Brazil, in South Korea, in Japan. I've used them extensively. For example, for pavements and roads, it can be used for pavement and road, for bridges, to check the integrity of bridges. I mentioned Abutu Alita Bridge, and I said presently we're also working on the Fort Mainland Bridge. For tunnel and buildings, we have done that extensively. For foundation and soil, that's under geotechnics. You can know the integrity, the strength of the soil, what part of the soil is good or bad. You can use to map underground utilities and void detection. For Guinness, Benin City, Guinness, Lagos, and Cadbury, we're able to use this to map underground utilities and void sensing. For substructural investigation for Athletic Gardens, at Ikoyi Foreshore 1, Foreshore 2, we have used this extensively, using substructural investigation. For transport, also evaluation of the fouling ballast. For this, we have not done in Nigeria because our railway system is not active. But I'm going to show you an example towards the end of this presentation where you can see that the tracks of your railway, the ballast along the tracks, you can monitor if they are defective or not. Airport, the runaway along the airport, you can also know if they are faulty. In advanced country, this is always usually been done. And for if you want to melt the structural steel, rebars, the stress that the cable. I was somewhere yesterday, at somewhere at Lekki, and where to look at something, buried cables by MTN, Glo, all these telecommunication company. If the cable have been cut or the cable is missing, you can use your GPR to detect that. And that's the second point. And it is also, you have to be, it will help you to know the area to avoid, so when investigation is being done. I'm not going to waste time. I want to quickly, as I said, I need about 20 minutes to do the presentation. I want to give some case histories. Some case histories. The first one here is from South Korea. When I was living in South Korea, 2003, 2004, this is a typical, this scenario came up. There's this 20-story building, and there's groundwater seepage, which is basically an engineering problem in the ground floor. This is the ground floor. So not until when there's a fracture, this oblique structure, this breakage, and this image here is a GPR image. So we're able to know that the building was sited on that fracture, and engineers who are brought in will know the width of the fractures, depth of occurrence of the fractures. This is quantitative, and they were able to remediate that fracture so the groundwater seepage could stop. That's a good example from South Korea, my office in South Korea. And here I'm just showing an example also that if you have pipes or cable buried in the subsurface, you can see here, it will see it in form, because that cable or that pipe is an hyperbola. It's a cylindrical object. So the EM wave will scan the top of the cable. So you can know if that cable is there or not. This is the example. So you're going to see that hyperbola. Once you see the hyperbola, you can know the width. You can know the width of the hyperbola, the width of the cable or the pipe that is buried in the subsurface. And the lithology of that environment also can also be effectively. And this is another example where we have concrete slab. I remember the case of Cadbury. Some cables were buried years ago, their generator room. So concrete were in the early 50s, but by 2018, 2019, the exact drawings of the location where this cable, where these concrete are, were not known. So we're brought in to look at it, and the concrete, the voids, the utilities that were hitherto unknown were effectively delineated. This is also an example of rebars. Also, somebody's reminded me here, and also at the British Embassy, Lagos, 2 years ago, were called in to scan the entire facility of the British Embassy in Lagos to find out where cables were buried, utilities were buried, which were hitherto unknown. So here I'm also showing an example of rebars. So this engineering rebar that is buried, and you can see the GPR image, that this image mimic the rebars that are buried. And also, I remember I will not mention this, but it's at Apapa. They have an underground, they have tank, a farm tank where they put petrol, where they put fuel. They found that some of the farm tank were tilting, building, bending. What caused the bending? They didn't know. Were brought in, and we used the GPR to scan, and we found that there is pit. There were pit, PEAT, underground at a particular depth. So those pits, we delineated the depth of the pit, and the pit was strengthened by our partner, Mindme Engineering. They strengthened it by injecting resin. So this is an example of a buried tank or a farm tank, and you can see here that the parabola, location of parabola shows where the tanks are. And also if you have buried cavities, that is Guinness. This is an example of Guinness, Benin. And what happens? They have cavities, and Coca-Cola also. I'm mentioning names. These are specific names that we have done, and Coca-Cola, that they are cavities, dissolution cavities. And we're able to use our system, the ground penetrating radar, to map the cavities, and remediation measures were put in or were suggested, and the engineers moving to solve the problem. I've also mentioned this dissolution or solution void, which I'm mentioning an example of Cadbury, Lagos, and another one also, if you have buried tanks, and in some locations, tanks are buried on the ground, cables are buried on the ground, pipes are buried on the ground, pipelines, and if those pipelines are faulty, or if they have problem, you can use ground penetrating radar to effectively. This example, I just copied it in from one of the work that we did at Ikatelegushi. I will not mention the name, but it's an hotel. They found that there were major cracks, 7-story hotel. Cracks were appearing on the wall. Structural engineers, they look at it critically. What happened? They could not define it. All their parameters were right. The hotel has been in place, but we brought in. What we found out, we were able to use our ground penetrating radar to scan up to 2-meter depth and to see the ground beam and the footings. From the footings, and we're able to know the soil type there, what happened to the ground beam, what happened to the pad footings. We're able to know the pad footing, one of the two, have already shifted, and the engineers moved in to stabilize those piles. And I said as an example from Bikati Elegushi, I will quickly run through the example from this is a beautiful one. If we are trying to deploy it for the Fort Mainland Bridge, there are some locations, Bayeku, Ikurudu, that we could not access, Aitoro, Ikurudu, we could not access. If you have access to the Mala Geodrone 80, the same equipment is flown all over the lagoon from Abraham Messiah down to across to Ikurudu, to a Greek in Ikurudu, so you can scan and see what is happening. This is an example. This is just a data given to us by Mala, Sweden. This is the trajectory of a survey line that the drone that I just shown flew, and it was able. It's an area, a difficult terrain that they could not access. At the end of the day, the river bank, the river bottom, or whatever, you can see that the bottom of the river, along that part, and the lithology along that part, and the structures, the near surface structures in the first 1 meter were effectively mapped, and the column of water, if I go back here, you can see the thickness of the water, you can know the water bottom depth. So if the engineers are to design the pie in that area, They already know depth to the top of the sediment. The water thickness is already known. So this Malageo drone, which is a drone system that has a GPR infused in it, will be able to map effectively the bathymetry. This is just a diagram also that is showing the bathymetry that was generated by the Malageo drone. And this is also another example of mapping utilities. You can see here, from what I've shown, you can see that a pipe is buried at this location, pipe buried at this location. You can map the utilities. You can see the layers of the soil that is dipping in such environment. This also another example of Mala Pro X equipment that is attached to a vehicle that is used in a built-up area. The beauty of it, don't forget I said, is a non-invasive technique in an area that is built up. You can effectively use it without disturbing the materials or the resources that is there. So also I said ballast, I'm going to give another example of ballast that is, we are not using railway in Nigeria that effectively, but you can use the Mala Geo drone, whatever frequency, 800 megahertz, 200 megahertz, 1 gigahertz, to map the track of the train or the railway. So if there's any defect anywhere, you will be able to effectively, this other example of ballast fouling level. So you can see the track of the train. You can see the GPR equipment attached to a vehicle and that is pulling it. So it's scanning, it's like a scanner, it's like a photocopy machine. It is scanning the tracks of the train. So I can effectively tell you what is happening along this. If I give you another, so you can see clearly here, what they're doing, they're having 3 antennas. These are shielded antennas, 3 antenna, antenna 1, antenna 2, antenna 3, shielded antenna, shielded in the sense that so that the EM wave will not scatter, that EM wave can effectively penetrate and scan the track, This is another model. This has not been introduced in Nigeria, but we plan to introduce it very shortly through Mala Sweden. And I'm winding down. Here I just give example. It's not that I'm that advertisement company, but there are varieties of companies worldwide that are offering GPR equipment facility. But for now, in Nigeria, we have the Mala Geoscience and we have the GSSI that are effectively on ground for usage all over the place. Here just listed the companies. So it's a matter of choice. If you're interested in buying or patronage, but I would recommend Mala because I've been using it since 1999. Since 1999 it did, and it has never failed. Here, I just show a typical example of feature or scenarios where we have worked using the equipment. The one on the extreme left here is at Lekki Gardens. No, sorry, Ikati Elegushi. The one in the middle here is the Fort Mainland Bridge. The one on the extreme right, is at Cadbury, Lagos. And you can see myself with Dr. Song in South Korea. That was 2003. I just got my PhD then, and that's myself and my colleague. And here also on the lagoon for the Fort Mainland Bridge, and also here this is the bistatic. Okay, the one that we're using is monostatic, but it is an example of what? Of bistatic antenna. When I say bistatic, the transmitting antenna and the receiving antenna, they are separated. One of my former students, Dr. Isaac, is in China, is the one holding it here. And also here is at Ikoyi for sure too. There's a swimming pool. We're given a scenario that no matter the volume of water they pump into the swimming pool is never filled up. The swimming pool is never what? Filled up. So we have to bring our equipment to scan the swimming pool, and we're able to know what the problem was or what the problem is, and solution were provided using our GPR equipment. And also the figure below here, the one is at the Kachelegushi, and the one on the extreme right is at the Benin Medical Center in Benin City. I have about 2 or 3 more slides, so I can. Here, oh, this is a beautiful scenario. The Nigerian Army, they called us in about 2 or 3 years ago. Very sensitive security information. That is Captain or Major Ada in black. That's the major of Nigerian Army. So the Nigerian Army took us somewhere. Some objects, which I would not like to mention in here, were buried, and we use our GPR equipment to scan the subsurface These are the members of the Nigerian Army, And this figure is taken from the WPS Canada. This is a design of a typical bridge for the Fort Bayland Bridge. So what we're doing along the path, I have about a slide more, along the path where the proposed 38.3 kilometer Fort Bayland Bridge is to be built, we pass through. We have been scanning for the past 30 days the path. So you can see if there's any defect, there's any fracture, if there's any subsidence, there's any settlement, if there's any structure that is buried along that path. The typical design, which I'm just trying to show. And the summary, the takeaway from this presentation is that GPR, georadar or ground penetrating radar, is a non-invasive technique, is a non-destructive technique, is a benign technique that is very effective for civil engineering application, which have tested between 1999 to date, 2021. And also in GPR, electromagnetic wave that is non-destructive, that is healthy, is passed through a transmitting antenna into the subsurface. And it will sense or scan the subsurface and give you accurate information. It's a matter of choice. You have to know, I've mentioned something somewhere that the depth of investigation of GPR is dependent on 4 factors: frequency, epsilon naught, mu naught, and conductivity. And also the center frequency of most equipment that are available in the market now ranges from 50 megahertz to 2 gigahertz. So depending on what you want to do, you have to know the range of frequency that you'll be using, like the Mala GPR equipment is a dual frequency equipment that you can use simultaneously. You can use that 2 frequencies to scan a particular environment. And finally, I would like to appreciate the following organization: Mala Genocide Sweden, Nigerian Institution of Civil Engineers, Maidu Engineering, because some figures that were shown, they are proprietary. They belong to Maidu Engineering, they are not mine. And they also belong to Korea Institute of Geoscience and Mineral Resources in South Korea. And they also belong to the WPS Canada. And the Nigerian Army is appreciated for the permission to share the information. Thank you very much. That's the end of my presentation.
Thank you so much, Professor Adekunle Abraham Adepelu. You've been able to do justice to the very interesting topic, even within short period. This is quite appreciable. Before I call on the nice chairman, can I quickly recap what the prof had just discussed with us? He's been able to discuss, especially at his introduction, the meaning of GPR, ground penetrating radar. And he told us about the history. He made reference as well. He made it clear that this is a scanner and it works even like similar equipment that we have around us. He also mentioned that it is so safe to use, that it is a non-destructive testing. It doesn't destroy anything. So it is a non-destructive testing. He also discussed the concept of this very particular equipment. It made known unto us how data is being processed, even when data are gathered through this equipment. Even though he said he wouldn't want to do too much on that area. He also discussed the civil engineering application. He gave case histories, which are very many in the course of his presentation. He also showed sample. Also, he listed companies where this equipment can be gotten, but he made it clear that he had been using one particular product. So he listed companies where this can be gotten. So he also gave us very many pictorial view of the previous work he had done with this very particular equipment called GPR. Also, he closed his presentation with a summary which has to discuss or which has to do with GPR, ground radar, ground penetrating radar. Thank you so much once again. We appreciate you on behalf of the NICE, that is Nigerian Institution of Civil Engineer in Osun State. Thank you so much. I've been seeing some questions in our chat bar. My chairman, sir, do I have permission to continue and coordinate the question and answer?
Thank you, Chairman, Engineer Set of Engineer, Oshobo Branch, Engineer Emmanuel Wadalonge. I appreciate you. You have my permission to take the contributions and question and answer session. But let's hear if there are comments or contribution first, so that the questions can follow. Thank you very much.
All right, sir. Thank you, my chairman. Do we have anyone that has contribution as regards what has been discussed?
Hello?
Engineer Adetuyi, can we have you?
Yes, sir. First of all, I want to appreciate our professor, our presenter, Engineer Adekule Abraham Adekale, for this. Okay, yes. Since today we are giving you this. Thank you very much, sir. I want to once again appreciate you for this laudable presentation. And this equipment, hello, sir.
I'm listening.
This equipment seems, yes, to us, it seems that it's new, but through your explanation, we have seen that this equipment has stayed over 70 years. And we thank you for opening our eyes to this equipment. And I want to say that through your explanation, this equipment will make the work of civil engineers easy, because instead of digging and doing some tests to some depth, this equipment, GRP, will just serve, and it will give an accurate answer because of the every other thing that are attached. So my contribution is that this equipment is going to help the civil engineers, that not only that we should hear it like this, please, like you have said, that how we can get it, I think we still have to contact you so that it can be more used, more in use in our society. Thank you very much, sir.
Let me quickly provide information there. Let me quickly provide information. Hello?
Yeah.
To the best of my knowledge,
yes, sir.
To the best of my knowledge, the
yes,
University of Lagos, Nigeria, they have capability and facilities for GPR. Mountain Top University, headed by the Vice Chancellor, Professor Yolabi, they have capability they have the equipment. And Obafemi Awolowo University and University of Port Harcourt. I'm aware of these 4 universities. I repeat, University of Lagos, Mountain Top University of Professor Yolabi, Obafemi Awolowo University and University of Port Harcourt. These 4 universities, I'm aware, they have this, and Osun State University, Osogbo. These 5 universities, they have the facilities. And some company, about 4 or 5 companies, independent company in Nigeria, they have it, but the usage is still very low. It's more of the university people that have been using it.
Yes.
Thank you.
Thank you very much, sir.
Yes, sir.
Any other contribution?
Mine is a question.
Chairman, sir.
Yeah, Engineer Abiola.
I can see Aliyu Ahmed Azare raising his hand. So I don't know if it's for contribution or for question, sir. Thank you, sir. Maybe you can put him on call.
Let him speak, please.
Hello.
I guess it's a mistake.
Mine is a question, sir.
Okay. Your own is a question. We are yet to get to the question points. We are taking contribution at the moment.
Okay.
So, but if no more contribution, we'll launch into the question and answer session.
My chairman, sir.
Yes, sir. Engineer Adedu Bright, please mute yourself. You are done speaking.
Okay, sir.
My chairman.
Yes, sir. Chairman, sir.
Hello, chairman.
Yes, sir. We can hear you.
Oh, sorry to call in. Along the line as the lecture was going on, I could see the National Vice Chairman for Southwest, Engineer Mrs. Lola Aditona, FNSC, F. Nice. Konajide Olayinka, Engineer Zare, Frank, then Engineer Elliot Akinshipe, the former chairman, Nice Ondo. I thank all of you, Professor Ayolabi, and all other too numerous to mention from National Council of Nigerian Institute of Civil Engineers. Thanks for being there. We recognize your presence. Many of you, you put slow name like Infinix 10 or whatever. Please, we recognize you all. Thanks for being there. Thank you, my chairman.
Thank you, sir. We will now start the question and answer, but before then, there is an observation put in our chat box by Dr. Mustafa Abdullah. He is the Mala GPR that is a brand of GPR representative in this region. He has his email on the chat box. That is mustafa.abdullah@guidelinegeo.com. So for further details on that equipment, he requests anybody can contact him through that email. So I think that can be taken as a contribution too. So thank you for that information. The first question on the chat box before I take other question. Professor, sir, are you on the call?
I'm listening, yes, sir.
All right, the first question is, how relevant is GPR to mineral exploration?
That's a good one.
Thank you very much.
The second question, okay, you want to take
quickly
it
answer
one
the
after
first
the
one, so I
other?
won't forget.
All right.
In the usage of GPR for mineral exploration started in Canada. It's been extensively used in Canada. And also, I'm aware that by some company, which I don't want to mention name, in Nigeria, in the Upper Benue and the Middle Benue, they have used it. Some company have used in Nigeria. It's very relevant for usage, for mineral detection. As I said, what to control the depth of investigation is the frequency, conductivity, the dielectric constant, and the permittivity constant. Once you get it right, the mineral deposit that is buried in the subsurface will be effectively marked or delineated. It's very relevant.
All right, thank you, sir. The next question is, what is the maximum depth of penetration of the signal?
Yeah, okay, it's a matter of choice. As I always say, now it depends on the frequency of the antenna that you are using. The conductivity, if you must know what's your depth of interest. If your depth of interest is 10 meters, you have to choose a frequency that can scan 10 meters. If your depth of interest is 1 millimeter, you have to use a frequency in the range of gigahertz that will, and you must know the conductivity, permittivity, and the dielectric constant. Some people will say clay, salt water, yes, some lossy environment, but you must be able to know the environment in which you are working. So by the time you're using the equipment, the parameter, the physical parameters for this can be setting so it can map what you are interested in. I'll repeat, the depth of investigation varies depending on the frequency, the conductivity, the permittivity, and the dielectric constant of the environment. That will determine the depth in which the GPR EM wave will penetrate. Thank you.
Thank you, sir. The next question is, can you please give an idea of cost this other probing method?
Can I repeat the question? Can I provide?
Can you give an idea of cost? I think they want you to compare the cost.
I would not like to talk about cost online. I would not like to talk about cost. You can consult the manufacturer. I'm just a consultant. I would not like to talk about cost. Mustafa.
No, I think, Prof. Sir.
Yes.
I think what the questionnaire is saying is, can you compare the cost of this GPR investigation with other probing method?
I'm a GPR addict. It has not failed me from 1999 to today. It is very effective. That's what I'll say. It's very compared to, that's why I stick to it. It's very effective. It's very effective. Right. That's what I'll say, please. Very effective.
Thank you. Okay, I'm still checking the chat box for further question. Okay, can GPR be used for groundwater survey as per aquifer location?
Excellent.
For
in such a case, yes, sir, it can be used. In such a case, if you want to use GPR for groundwater exploration, it's being used extensively in Brazil, where it's cold. You have to use extremely low frequency. What is done in such a scenario? You have to use between 15 megahertz to maximally 100 megahertz. That is what is suggested. You have to use for groundwater exploration, yes, but you have to use a frequency antenna that ranges between 15 megahertz to maximum 100 megahertz. With that one, you can be able to scan between 300, between 30 meters and about 300 meters.
All right. Another question here, sir. How well is performance of GPR in salty water? And what will be the typical water depth that can be achieved? I guess you have answered the question.
Yeah.
So, but that is, how well is performance of GPR in salty water?
As I said, where I'll give an example in Lekki around Chevron. There's an estate called Buena Vista. Buena Vista. In 2005, we deployed. We know there is saline water intrusion in that environment. So for you to use the equipment, as I said, if you don't set the conductivity, the dielectric constant, and the permittivity parameter right, you will not be able to map the saline water interface in that area. You must get the parameter right, but if you don't get it right, you will not be able to map the saline water intrusion. We have used it. I've measured the place at Buena Vista, around Chevron roundabout, and it has worked. We have used to delineate freshwater and saline water interface very effectively.
All right, sir. Another question, can the GPR be used in absence of as-built survey?
I don't understand that question.
Can the GPR be used in the absence of as-built survey? So that is how he wrote it. Also, I don't think I can pick the question.
It's always good. What I do, even that's why I use GPR, I still drill 1 or 2 boreholes as a control. I'll give an example. At Badia, if you know Lagos very well, if you know Buri, Jora Buri, at that corner, there was a time we were to build the Fuchsia Williams flyover, and we're brought in.
Hello, sir. I don't know if I can intervene.
Yes, sir.
Professor Ladap on the line.
Yes, sir. Where?
Yeah, that question, whether GPR can be used as a build survey, yes. For studying structures, subsurface structures, or rather substructures, that is foundations of buildings, you can adopt GPR to investigate it, but your frequency must be sufficiently high so that it will pick shallow concrete structures. Then for reinforcements in concrete, you can also adopt GPR, but with very high frequency so that you can establish the position of the iron rods. So GPR can be adopted for as-built survey, as by that question, the person who raised the question.
Thank you, Professor.
I think that should be okay.
Thank you, sir.
Thank you, sir.
Yeah.
Engineer Bright, you are still causing interference. Your mic is on. Please mute your mic. Engineer Bright, how did you? Next question, sir. Can the GPR be used to dictate rupture, leakage, gas pipeline? Then what is the maximum depth of investigation that has been taken? But the first part of the question, please, can GPR be used to detect rupture or or leakage on gas pipeline?
Yes, sir, it can be used. And in such case, you have to use the high frequency, like Professor Ladapo said. It has to be in the range of gigahertz. 1 gigahertz to about 2 gigahertz. It can be used so it will scan and effectively monitor and map where the rupture is. It can be used. And I know a company which I don't want to mention is at Alpha Beach, Lagos. That is what they do. Pipeline monitoring for Shell Petroleum. That is what they do, using their own GPR. They have GPR facilities also. That's what they do. They've been doing it for long.
All right, sir. Another question, or someone says, it will be interesting to know how the data generated via the equipment are analyzed. He also
Go ahead.
He also said, what are the nature of material that will be detected with it?
Any material can be detected. Any material. Okay. Wood, anything can be detected. As per the processing, myself, it was after I got it took me 6 months to become a master in processing. Processing of GPR data is not something that you just, but some equipment like the Mala come with good processing software that can be learning within 1 or 2 days. It's easy and it's a bit difficult also.
All right. He also asked, what are the format of the report generated?
No. You cannot format. You are the one to write the report your own. Or say the question is, what's the format of the data? The data will be in RAD format. RAD, R-A-D. It can be in RAD. It can be in Prosecco format, DTI. It can be in Segway format. Depending on the company, there are various formats in which the data, but there's a universal format which you can, your data is acquired at a particular format, you can convert to the universal format. I hope I've answered the question.
Yeah, you at least. I'm still looking at the chat box. If more other question.
Yes, more other question.
Professor Elabi is raising his hand, please. Professor Elabi is the Vice Chancellor of Mountain Top University.
My chairman, let people have questions to ask. They can ask our questions that are no.
Another question from the chat box says, is that how, my question is that how can we get the lecture material and certificate of attendance? So as in your presentation, that is the only one you can answer. The nice chairman will be able to tell us whether we are going to be given.
As per the presentation, I've already given nice permission to distribute.
Thank you,
as many people that want it, you can give it to them.
Okay, we'll discuss that later. Thank you.
Please, Professor Elabi will give him floor to speak. He's the Vice Chancellor of Mountain Top University, please. And he's an expert on GPR in Nigeria.
All right. You still have more questions. So before we give him the permission, this question says, can GPR also be used for location, stroke identifying leakage in mechanical plumbing, pipe boring? I think you have answered that
Is
question since it can
extensively
be
being
used
used
on the
in Europe.
pipeline.
Yes, sir. It can be
So,
used. It can be used.
Does another one is, does the GPR have laboratory application? That is, can it be used for measuring soil property in the lab?
Excellently, yes. It is available. The small model is available. For the laboratory model, is available.
Another question from Dakwade Poju says, what is the resolution that is typically achieved? That is, how far away from point of investigation is image?
This is a contentious question. There are some people who say GPR has a poor resolution. The answer is capital no. The resolution, to the best of my knowledge, is far better than the resolution of seismics. It has, to me, very good resolution.
All right.
Very good resolution.
From Kola Oliola, how can we increase the resolution of the GPR data?
As I said, the resolution is dependent on the frequency. You have to know the environment in which you want to work, so you can know the appropriate frequency to be deployed. If you deploy a wrong frequency to a particular scenario, you are going to have a poor resolution of the subsurface or the superstructure that is available. You must know the right frequency to be chosen and the physical parameters of that environment.
All right. Said Tijani, your question had been answered. Please contact Nice Oshun. That is for the lecture material. The last question here, what are its limitations? And is there any health implication? The later part had been answered. So no health implication according to the lecturer this evening.
According to the world standard. According to the world standard. But now, there's no health implication, major or minor, has not been reported anywhere in the world. Has not been reported. Now.
So is there any limitation to it?
Yes and no. The limitation in some cases is use of clay. Clay. In such a case, if that clay, because clay is known to absorb EM wave. Clay absorb EM wave. So if you have extremely thick clay, the clay might absorb extremely thick. It might absorb the EM wave. In such a case, you don't allow the electromagnetic wave to penetrate. So in such scenario, a controlled drilling has to be done in that clay environment so I can obtain information about the permittivity, the dielectric constant, and the conductivity of that clay, so I can be modeled in the laboratory so that the information obtained in situ can be incorporated for appropriate data acquisition.
Thank you so much, sir. We have two people raising their hands. Can you please speak out?
Hello, sir, my chairman.
Yes,
Chairman, sir. Before that, sir, there is a question written by somebody that, is there any earth hazard in connection with the use of?
I've answered no.
Yes, he has answered.
It's no. Earth hazard is no.
Negative. Okay, thank you, sir.
Another question.
Professor Ayolabi, I can see you raising your hand.
Okay, thank you very much, sir. I want to thank the organizers of the program. I also want to thank the presenter, Professor Adepelumi, for the wonderful presentation. Well, I just want to sound a little bit of caution when it comes to GPR application. Well, the presenter has told us of several applications of GPR and how effective it is. Yes, GPR is effective, but it has to be treated with caution because in some area it will work, in some it will not work. So it does not work in every situation. Even though the presentation sounds as if it works in all situations, no, that cannot be true. It does not work in every situation. There are some occasions your GPR will not work. For engineering applications, yes, it works for most of the things, but when it comes to foundation studies, I will not advise anybody to rely solely on GPR because number one, it has limited depth of investigation. Even with the best of frequency, the 15 megahertz, you cannot get to the depth of 300 meter, 100 meters. No, it has a limited depth of investigation. And when you are working in a very conductive area, you may not get the right result because the conductive medium will actually absorb your EM wave, and you might not get reflected data to process or interpret or to give information about the surface. So these are things we must know so that we don't raise our hope beyond the what is expected. And when after going out with it, and then we think it does not work. Yes, it works in some situations very well. There are some situations that caution has to be taken because it may not work. So the conductivity, as he said, very, very important. Even with the best of laboratory model, there's limit to the depth to which your GPR can reach because we know the frequencies. And the low frequency that can penetrate the depth of 300 meter, I am not sure that has been produced from the knowledge of GPR that I know. Somebody talk about processing. Processing these days with the Malavision, you might even not need any major training. With Malavision, under 30 minutes, you know how to process your data because everything has been incorporated. So you can easily get your result and then get the output easily well interpreted because all the parameters have been incorporated. So these are some of the key things I want us to take note of. Even though GPR is very, very good, but we must treat it with caution. It's not applicable to every situation. It cannot pick every situation. And I think we must take note of that. It is not a panacea to all problems. It has its own limitation and it has its own effectiveness. Thank you very much.
Thank you for your contribution, sir. I have Arowolu Oluwaseun raising his hand.
Thank you very much. Good evening, everyone. Thank you, the presenter. I'm grateful for this lecture. So please, my own question is tilting towards knowing the depth of the reinforcement, because I do more of assessment, structural assessment, but looking at the lecture presented, part of the presentation, whenever, I mean, in those profile showed the GPR only show the curve of probably where they are metals. I want to ask if the GPR perhaps shows the thickness, because when we are talking about structural investigation of we want to know where rivers are, it is important also to know sometimes the thickness of reinforcement that are there. So I want to ask if GPR can give information about the thickness of reinforcement in slabs specifically, or in foundation, or whatever structural element. That is my question.
Prof, sir, can you quickly take that?
Yes, to the best of my knowledge, yes, it will give. I've tried it severally in several locations, Nigeria, in South Korea, Brazil, and it works. It can give you the thickness. It can, if you choose the right one and the right frequency, it can give you the thickness.
Thank you, sir.
Not too deep. If it's not too deep, it will give you.
Thank you, sir.
Thank you, sir.
Engineer Felix Adeniro Ogini, FNSC.
Yes.
You have the floor, sir.
Thank you very much. My question is, what is the area of influence of the GPR? What I mean by the area of influence is horizontally, what kind of area can one be talking of before going deep down vertically?
For you to get the area of influence,
that's right.
It's always better, as I said at the beginning of the lecture, second or third slide, there are two types. We have the monostatic and the bistatic. So if you want to have a good coverage of area of influence horizontally, I would advise to use—
No, not horizontally, vertical. I mean, yes, horizontally, that's right.
Horizontally, I would advise that you use a monostatic antenna. With a monostatic antenna, at every 25 millimeters, you'll be getting information. At every 25 mm, you are getting information.
25 millimeters.
Yeah.
That looks too tiny, sort of, isn't it? Is it 25 millimeters by 25 millimeters?
it is a continuous process. You are dragging or you are moving. So at every 25 mm, reading,
all right, okay.
Scanning is done continuously in a continuous profile mode.
Okay, continuous profiling. All right. Okay. Thank you very much. The other question is, yes, you've been mentioning some schools have been involved in the use of the GPR. I want to say, is there anything that says, oh, you cannot penetrate some other institutions? Not just universities.
No. For example, let me mention Mountain Top. Please, permission, Professor Yolabi. Professor Yolabi is a professor at UNILAG. He became a vice chancellor at Mountain Top. So at UNILAG, he has been using the equipment, the modern equipment. So when he became the vice chancellor of Mountain Top University, he introduced the concept to them at Mountain Top. Myself, I've been a staff at TFS since 1995. I've been using this since 1999. I introduced the concept to my university. It's not that it's a matter of choice. Who is there in a particular university that has interest in it? It's interest that matters.
My point is, hello. Yes, my point is, it does not really matter whether one had been using it before it gets to somewhere, but while suppose we begin to also consider extending that usage to other institutions.
That has been in place that I'm aware of at Mountain Top University, IFE. They, from time to time, Osun State University, they have this facility at Uniport. They rent it out to sister universities that want to go on fieldwork at a minimal rate for their fieldwork.
I'm probably FUTA.
I'm a graduate of FUTA, 1990. I'm not aware if they have the facilities. We have Professor Ladapo here. He can answer that question.
Okay.
From Professor Ladapo. I introduced the concept of GPR in FUTA in 1998.
Good.
And what caused it was, 1998. Yeah, that was when I introduced the concept of GPR in FUTA. And it was born out of a course we introduced there. We called it environmental geophysics. And it was also a product of my experience with Shell when they had a problem with one of their oil wells. They brought in a geophysicist with the GGIS from Florida, Matthew Turner. So I worked with him and we processed the data using the, theory of using electromagnetic theory, and we're able to identify features of interest from that operation. It was a largely successful operation then. It was one of Shell oil wells in the Uweli area. So I brought the concept to FUTA in 1998, and we've been teaching that course. In fact, we've introduced up to PhD level for people who are interested. Fortunately, FUTA does not have the equipment, but we readily get from private concerns. And I personally have been operating GPR since that time, on major projects in Nigeria. And it has worked. One of that is the reason why we did across the River Niger, and the result was fantastic. And we have used it on several other environmental, engineering, and pipeline studies across the country. Major oil pipelines, like the AKK project now that they're talking about. So it's fantastic. It depends on who is using it. And of course, maybe because I had some background in civil engineering, so I know how to adapt it for civil engineering work. So we have the course in FUTA, we teach it, and we produce graduates in FUTA.
Okay, thank you very much. It's been really interesting, and yes, some of us have had to listen and also acquire some additional information. Thank you very much, and Michael Ladapo. I'm done. No other question.
I guess all questions had been taken care of. So I want to hand over to the chairman Nigerian Institution of Civil Engineers in Osun State, Engineer M. Olanioye, to kindly take the vote of thanks before we launch into the closing prayer.
Thank you very much, my chairman, the able chairman NSC, Engineer Emmanuel Alonga, for the job well done. I don't know if Engineer Bashir Abiola, the PRO, is around there, because we are for to be presented to our guest speaker. However, if it's not yet around, I want to appreciate Professor Oladapo, Professor Ayolabi, Professor Felix Adinogini, FNSC, FNICE. Also, in a special way, Engineer Dawood Ilani, all the way from Kaduna, Engineer Ali Ahmed Azare from Abuja, Elliot Akinshipe, engineer, former past chairman, Nice Ondo, Engineer Frank Ikwewan from either Abuja or Port Harcourt. And one of our headers, Ademola, and all our people here. And finally, Engineer Mrs. Adeton Lola, representing the chairman, regional chairman, here. She's the vice chairman, Southwest. Well, when we started, it's a big fish that we have been able to catch. About sometimes last month, I had opportunity to listen to Professor Abraham Adepelumi on NTA2 when he was talking about the solid minerals, describing about the beneficiation of solid minerals. When I listened to him, I know it's well loaded, and I've been anticipating how today will look. But to God be the glory. I'm not disappointed, and I believe everybody must have been well fed. About this test, I want us to know that professionally, all of us have one thing or the other to learn. We don't need to know everything or do everything on our own. When I was to determine the water table at certain places along Ilesha Akure about 12 years ago, when that road was very bad and I was a student at FUTA, I have to hire the service of people from geophysics from Akure to determine the water table at different locations using either resistivity method, I don't know all those things. My own is to get the message, to get the information and use it for my own purpose. And I think the same thing is applicable to all other professions. Today, we have been educated that even whether electrical, mechanical, geologist, and so on, we can make use of this method for investigation because it's non-destructive. I want to appreciate you once more, Prof, for honoring our invitation. The lecture has been very informative, it has been very educative, and it has created much more awareness. So I want to assure those who have indicated interest in the paper that soonest you will get the soft copy, but Prof will leave you with the number of Prof so that for his services. Prof was called to Abuja when we had the air tremor at Abuja some times ago. I've been monitoring him. You may not know me, but I'm monitoring you on the ground. That is why we search and had to use Engineer Dr. to bring you down here.
Thank you,
So
sir.
thank you very much for honoring us. I appreciate everybody who has participated in one way or the other and who has contributed. And finally, I want to appreciate the state chairman, the NSC Oshobo chairman, Engineer Wale Emmanuel Alunge, for coordinating the program very well. Thank you. We hope next when we call you for another talk and maybe recommending you to our national conference. I hope at Abuja you'll be there to do justice to possibly the same topic in another, the same topic or the same procedure, method, technique in another dimension. So don't be surprised because we want to send you to that place.
Thank you very much.
Don't disappoint us.
Thank you very much, sir.
Very much. I thank my technical crew too and all the executive member of NICE here. Once again, thank you and God bless. Is Engineer Bashir Abiola still on?
Yes, I'm on, sir. I'm on, sir.
Oh, do you have
I'm on, sir. No, we don't have it. So we'll present it physically to him, sir.
Okay.
Unfortunately, we don't have it yet, sir.
Okay,
Yes,
thank
sir.
you very much.
Yes, sir.
Engineer Emmanuel Wale Alunge, my chairman, over to you, please.
Thank you so much, sir, for the honor. I'm at your service. I'm doing the work you have sent me. We appreciate everyone. Thank you to our leaders. Thank you to our babas. Even though many a times we wouldn't find a young one monitoring a call like this. And if people like Engineer Felix Adeniro can be so passionate and be on course like this, it is highly challenging to the youth. Baba, Ọlọ́run á lọ́ra mi, á rí yín pẹ́ o.
Ẹ pẹ́ fún wa o.
Àti àwọn bàbá tó kù, Bàbá Adémọ́lá àti gbogbo yín, thanks you for leading us well. May God spare your life even to live long in good health. Thank you, sir.
Thank God.
We'll be taking the closing prayer as directed by the chairman. It is the national anthem, stanza 2. We will chorus it together to close this August technical session. I believe you can all see my screen.
Yes.
Yes, sir. Yes, sir.
Yes.
Okay, thank you so much.
Yeah.
At the count of 3, we will chorus it. 1, 2, 3. Oh God of creation, direct our noble course, guide our leaders right, by you the truth to know, in love, honesty to grow, and living just and true, with love to hide that thing, build a nation where peace and justice shall reign. Amen.
Amen.
Thank you all.
Thank you, sir.
Baba
Thank you.
Baba,
Thank you very much, sir.
Thank